Can you tell me how the universe started?
Bang!
Here we are, the inflation phase. Here, you can see the universe expanding very, very quickly.
Less than a second has passed, and neutrons and protons had already gotten together.
Yay!
However, electrons can't join in yet, as they're simply two.
Hot.
Protons and neutrons have joined to become deuterium.
3 minutes have now passed since the start of everything. And look, we now have hydrogen and helium.
There's even a little bit of beryllium and lithium as well.
Look at this graph.
380,000 years later.
The temperature has now decreased enough to make electrons able to move around atoms.
Zoom.
The electrons are leaving behind trails of themselves. Interesting.
This is the time that background radiation was created. The background radiation comes from remains from early atoms.
Because of the lower temperature, neutral atoms have been created and the electromagnetic radiation can pass through, and gravity is bringing everything closer together.
We can see the first ever star. It is 200 million years after the very beginning. Many stars were born, and all of them died.
R.I.P.
Let's skip ahead just a few billion years to our time to see more about how humans learned about this.
There are 3 main observational proofs for the Big Bang, which are the background radiation, the expansion of the universe, and the distribution of elements in the universe.
The theory that the universe is expanding came to light by a man named Hubble in 1929.
You know how big people, who are getting even bigger, goes on diets? The universe doesn't do that. The universe is all for body positivity, and will therefore never stop expanding.
If the universe never stops expanding, that means that it had to have a starting point within a tremendous density, which is the Big Bang. Picture a balloon with 2 dots on it.
If you blow up the balloon further, the dots will not have moved on their own, but the distance between them will have increased.
Background radiation is another observation that supports the Big Bang theory.
There is background radiation chilling everywhere.
Why?
They just started chilling around after all of the energy released from the Big Bang.
And they're really, really cold, like 2.726 Kelvin cold.
The third main observation that supports the Big Bang theory is the distribution of elements in the universe.
Through lots of research, scientists have deduced that the universe consists of around 75% hydrogen, 24% helium, beryllium, and lithium, and other elements make up around 1%.
After the Big Bang, the universe wanted to create stuff, because why not?
And that stuff later turned into atoms. Atoms are really, really small, super complicated building materials, which in reality is either explosion gas or funny voice gas.
Both of these fun gases fill space because of the energy the Big Bang created, plus the minimal resources it needed.
So you got everything?
Alright, you can ask questions about anything you're wondering about.
What is the meaning of life then?
42.
Okay, how did the universe expand so fast in the inflation phase?
That's a good question. We
Yeah.
really don't know, but it would be very interesting to find out.
In the future, we might find out more if we can observe gravitational waves from this time.
Oh, okay, so what is dark matter?
Dark matter is a material that cannot be seen directly and do not absorb or reflect light.
Wait, if dark matter cannot be seen, then how do we know it exists?
Well, scientists study dark matter by looking at the effects it has to visible objects. We do not know exactly what dark matter is, but we have not been able to observe it on the electromagnetic spectrum.
Whatever dark matter really is very complicated. It will probably take us a long time before we truly understand it.
Okay then, but how do we know what the universe consists of then?
A really good question. There's this thing called spectral
I haven't
lines
been
that
looking too
all
quickly.
atoms lay behind. These spectral lines are unique for each atom. We can see what kinds of atoms are around us by observing these light waves. We can also see how dense or how hot the atoms are. We can see how fast they are moving, and they can tell us about the magnetic field around the star. Spectral lines are truly amazing.
Additionally, electrons can lie in three different heights around the core based on their energy. The greater the energy, the greater the distance from the core. Whenever an electron charges high, some of the energy is lost into a photon that emits light.
This photon can be picked up by other electrons to be again lifted up to a new height. The light that escapes, however, are all different in size, brightness and color based on which element the atom is.
That is
And
all we
that's the
got for
universe
today.
and the Big Bang.